Hello, and today we're going to be talking about the CPU. Well, what is a CPU? It stands for Central Processing Unit. And if we take a look at this image, well, you may not see much, but to a computer enthusiast's eyes, this is a lot. In the middle, you the Central Processing Unit, or basically the brains of a computer. And inside that are lots of transistors and cores. Nowadays, at least in 2020, there's most CPUs have up to 4 cores, some even 16, like the Ryzen 9 5950X, which you cannot find in stock currently. But what is it? It's basically the brain. Like as humans, we have brains. That's basically the CPU. It's basically the brain of a brain. It's basically the consciousness, or in CPU terms, it's the central processing unit. Well, this is what a CPU is. So yes, what does a CPU do? Well, it fetches data, decodes it, and executes it. Well, I'm pretty sure you don't know what I mean. But basically, for example, let's say you want to brush your teeth. So, from our brain fetches the data from our memory. For example, our brain, it fetches the data, which is basically what a CPU does. Let's say you want to know, I don't know, let's say you want to search up the coronavirus. Why is the coronavirus named the COVID-19? What this does is that it takes the instruction from the RAM, it fetches it from the RAM, just like we do from our brain, and then we decode, and then we execute the data. But in computers, you can't just execute the data, because computers decode the data in binary, in ones and zeros. For example, well, I guess you're gonna ask me, hey, why does a computer take the time and waste its energy on decoding the data when it could just execute it? Well, like us humans, we use English. Well, at least most of us. Just like a computer, it has its own language to communicate with other computers and servers. And this is used in ones and zeros because this is the most efficient way to store data and takes the least space to do so. And most of these are combinations of 111, 00011. As a matter of fact, there's almost 10,000 combinations you could use, and new ones just keep coming. So yes, it decodes the data. It takes the data, it decodes it, so it takes the ones and zeros, takes it and makes it, and then fetches it from the RAM, which comes in ones and zeros, decodes it, which makes it into English or whatever language you're using, and then it executes it. So it does the task. What it does is that it basically executes it. Like if you press search for what's the coronavirus, it basically does that. And then it gives our answer, which is after it executed it, it's going to display it, which is what the GPU does, which basically shows it. And yes, that's it. That is what a CPU does. And there's more things a CPU can do. It not only that, but you can play games with it. As a matter of fact, if you don't have like an RTX 3090, or for example, let's say you're playing at 4K, it's going to be more heavily bottlenecked on the GPU. But if you're playing at 1080p at like CS:GO 600 400 FPS, you're most likely it's their CPU which is pushing out those frames. And most games these days are single-threaded lows or use only one core. As a matter of fact, most gaming CPUs have up to 16 cores. That's a normal gaming CPU would have a minimum of 4 to 16 cores. And games are only single-threaded. Most games, like 99% of them. There's only 1% of games who utilize all the cores, but we're not going to talk about that. But yes, another thing a CPU can do is render things. For example, let's say you want to render a scene. Like it's basically, let's say there's For example, let me just show you this picture. It's called Cinebench 5. It basically, you can use your CPU to render things. For example, you have your RAM, and there's the program which is stored in the server, and the server takes it from the RAM, and the CPU takes it from the RAM, decodes the data, which is basically some really complicated stuff, which I don't know, which is only up to professors, but it's really complicated. Basically takes these like a millions and trillions of these ones and zeros, decodes them, and then executes them. So yes, that's what a CPU does. So yes, this is the origin. This is the Intel 404, which was made in 1960 by Federico Fagin. He was an Italian physicist who invented the first commercial CPU. It was the Intel 4004, and it was released by 1971. And guess what? It only had 1 billion transistors, which may sound like a lot, but trust me, this is up to 1,000, 10,000 times less than how many transistors we have today. This had a clock of a whopping 750 kilohertz, which may sound like a lot, but isn't. This is up to 1,000,000 times slower than an quad-core i7 processor. So now, if you're going to ask me, hey, if all CPUs are the same, then why do some CPUs cost more than the other? And why do some have more performance than the other? This relies on three major factors: the clock speed, the architecture, which is represented in nanometers nowadays, and most importantly, how many cores and threads it has. So, let's take an example. A Core i3 and a Core i9. This i3 has a clock speed of 3.4 gigahertz and is a dual-core processor, which means that its maximum speed, or clock, is measured in gigahertz nowadays. It's basically gigacycle, so it can do 3.4 gigahertz, which is basically a gigahertz is 1 billion. That means it can do 1 billion operations per second. That's right. It may sound like a lot, but it actually isn't when compared to just running Chrome. As a matter of fact, Windows requirements are 1,200,000,000 clock cycles per second, which is basically 1.2 gigahertz. And we abbreviate this, so whenever we're comparing, we don't have to say, this processor is 4.373 million gigahertz, and this one is 7.3 something something something. This is so we don't have to say the extra zeros at the end. That's why we have these abbreviation as gigahertz. Now, what's the difference here? An i9 will most likely have 8 cores, and an i3 will have 2 cores. This means that an i9 processor has 8 CPUs in it. Is that mind-blowing? That's right, they put 8 CPUs in it. Well, not so exactly. A CPU, well, at least from the middle of 1995, most CPUs only had 1 core, and only the servers had 2 cores. And a CPU, like I said, a core is basically 1 brain, and each core is basically a brain. So it's basically measured in 4 brains. So basically, in the terms of brains, an Intel CPU has 8 brains, and the i3 has only 2 brains. So that means that this Intel CPU can so-called split the same task and do it 4 times quicker than the i3 processor, which isn't always the case, but this is just an example. Because since there are more factors than just cores. As a matter of fact, there's 2 more. There's this clock cycle. Like I said, a clock cycle. Let's say there's this CPU which runs at 2 gigahertz, and the i9 runs at 4. let's just say the i3 runs at 4 gigahertz and the i9 runs at 2 gigahertz. What this means is that if it has 2 cores, it makes it have 4 cores, since each CPU's clock speed is 2 times faster than the Intel's ones. So that means it's basically equivalent to 1 Intel core is equivalent to 1 i3 core is equal to 2 Intel i9 cores, which means is that its clock speed, it doubles. As a perspective, let's say there's one runner and he runs at 10 miles an hour. Another one runs at 20. But you have a team, and in your team there are 4 players, and your next team have 8 players. But the team with the 8 players can only run 10 miles an hour, while the team with 4 players run 20 miles an hour. So, let's say we take an hour, and we want to measure how much distance each team is running. How much? Let's just say they ran at a steady rate. Since the team with 4 players ran 2 times faster than the team with 8 players, this means that they would have covered the same distance in the same time. This is the same with CPUs. And the final one is threads, which is basically a virtualization and hyperthreading. This means that the CPU cores can work together. This makes the CPU cores double.